Welcome to the first video of the year. This is section 2.1, 2.3, functions, direct variation, and equations of line. They all kind of merge together, so we're going to kind of go through them quickly. First key vocab word is a function is a relationship where each input, or the x value, has only one output, which is the y value. So when we test to see if it's a function, we look at the x values and the y values and see what they're paired up to. Notice that in our first point, or our first set of points, -3 is grouped with 4, 3 is grouped with 1, 4 is grouped with -1, and 4 is grouped with 3. Because 4 is grouped with two different numbers, this is not a function because each input does not have only one output. Over here to our second group of numbers, we see -3 is grouped to 14, 0 is grouped to 7, 2 is grouped to 0, and 9 is grouped to -18. Each input has only one output, so this one is a function. A nice little trick is to look and see, are the x values listed only once, or are they listed twice? If they're listed twice, chances are it's not a function. They'll also give us mapping diagrams to look at. The little arrows are saying which number that input is grouped to. So 3 is grouped to only 4. Or sorry, -3 is grouped to only 4. 3 is grouped to -1. 4 is grouped with -1 and 3. So since it is grouped with more than one output, this one is not a function. Over to the right on our second group, 0 is grouped to -7. 1 is grouped to -7, and 5 is grouped with 3. Now, don't let this confuse you. Remember, our rule is that each input has only one output. The outputs can have many inputs as we want. So, 0 has only one grouping, 1 has only one grouping, and 5 has only one grouping. So this one is a function. When we look at graphs, we use something called the vertical line test. Vertical line test basically means that you go through the graph and you draw a vertical line at any point. If this vertical line passes through the line of the function or the graph of the function more than one place at any given point, then it is not a function. So here it only crosses the graph at one point, 1 point, 1 point, 1 point, 1 point. So since it only crosses the graph at one point, it is a function. Over here to the one on the left, if we drew vertical lines through, yes, this vertical line only goes through one point, but this one here would pass this graph at 3 separate points. So because there is a line that exists that crosses through this graph at more than one point, it is not a function. Now, we're going to embrace something called function notation. This is where they say f of x equals. Now, something interesting about f of x is that f of x is basically the same thing as y. The only difference is that when it's f of x, we know it's a function no matter what. So each input has only one output. So going through, whenever they write f of x, it means that x is going to be our variable. When they change x to be a number, that means they want you to plug that number in for x. Where we get confused is that we're going to keep f of -5 on the left side. We're not going to solve for f. We're going to solve for f of -5. So when we plug our numbers in, -2 times -5 minus 1 over 3. Order of operations, we'll do our parentheses first, and inside our parentheses, we'll do multiplication first. So -2 times -5 is -10 minus 1 over 3. We'll go through, subtracting is the same as adding a negative, so that's -10 plus -1. We'll get a -11 over 3. A negative times a negative makes a positive, so our answer is +11 over 3. And notice we did not divide by -5 at the end. We keep that f of -5 there, equals f of -5. Now, I know that this video is going through quickly, but the idea is that you're in control. You can pause it, rewind it, rewatch what you need to watch. So if you've missed anything at this point, go back, look it over, check it out, okay? You don't have to keep going with me at the same pace. Lines. We're getting into equations of lines now. This is slope-intercept form, and the reason is that we have a slope, that's our m, and we have a y-intercept, that's our b value. Y-intercept is where the graph crosses the y-axis. Whenever the graph crosses at 0, this is called direct variation, alright? Often we will write it as y equals kx instead of y equals mx, just because somebody felt like doing it that way. K is called our constant of variation, but it's still just like the slope. Don't let all of this mumbo jumbo confuse you. It's still slope-intercept form. The only difference is that it crosses through the y-axis at 0. So when we want to test for direct variation, we need to look for a pattern. Remember, direct variation is just y equals x times a number. So if we want to look here at the table on the left, 2 to 6, what do we multiply by? Well, we multiply by 6. 3 to 18, what do we multiply by? Well, we multiply by 6. And 5 to 30, what did we multiply by? 6. So yes, this is direct variation, and this is where we multiply x by 6. Off to the top equation, is this direct variation? First we want to solve for y, get it to be a y equals equation. So we'll add 3x to each side, and we get y equals 3x plus 7. So even though this is an equation of the line, because we have that plus 7 there, it means it doesn't cross the y-axis at 0, so this one is not direct variation. And then looking at our graph, we have a line. It crosses at the y-axis, so yes, this is direct variation. If we wanted to figure out what the equation was, we would check for the slope, rise over run, which we'll get into on the next slide. Up 1, right 1, 2, 3. Up 1, right 3. So our equation would be y equals 1 over 3x, because remember, our k, or constant of variation, is just slope. Slope is rise over run, or y2 minus y1 over x2 minus x1, and that's just when you have a point x1, comma, y1, and x2, comma, y2. You will just plug those numbers in. The 2's are from the same point, and the y's are from the same point. When we look at a graph, it's rise over run, so if you wanted to calculate slope, you would pick 2 points that clearly cross the grid. To get to that point, you calculate the lines traveled. Up 1, right 2, and so our slope of this line is 1 over 2. Our slopes can be positive, negative, 0, or undefined. We read it kind of like a book going from left to right. So if going left to right, it's increasing, that's a positive slope. Left to right, it's decreasing, that's a negative slope. If the line is just a straight line, we have a 0 slope, and if it goes up and down, that's an undefined slope. So I know this video's getting toward the end, but let's go ahead and calculate some slopes. We'll do just a few examples, and then we'll be done. Find the slope of a line that passes through the points 5 minus 2 and 5 comma negative 2 and 3 comma 6. It doesn't matter which ones you select to be your 1's and your 2's. All that matters is that the 1's are from the same point and the 2's are from the same point. So y1 minus y2 over x1 minus x2. Again, it doesn't matter the order you do that, as long as the 1's are from the same pair and the 2's are from the same pair. So I'm going to go ahead and I will do 6 minus negative 2 over 3 minus 5. Minus a negative becomes plus a positive, and that becomes 8 over 3 minus 5 is negative 2. We simplify that. 8 divided by negative 2 is negative 4. Our slope is negative 4. Graph the equation. 2x plus 3y equals 6. Let's go ahead and write that in a form we know. So 2x plus 3y equals 6. I'm going to solve for y. So first I'll subtract 2x from each side. And I get 3y equals negative 2x plus 6. Then if I want to get y by itself, I need to divide by 3. And when you do that, you will divide everything on the right side by 3. And we get y equals, first we'll do this division, negative 2 over 3x. Then we'll do this division. 6 divided by 3 is 2. Now we have this set up. Our slope equals negative 2/3, and our y-intercept equals 2. We'll go through and graph that. You start with the y-intercept at 2. Then our slope is negative 2 over 3, so we can go down 2 and right 1, 2, 3 points. Notice the path. You start at the y-intercept, you go down 1, 2, and you go right 1, 2, 3. The reason is down is a negative, right is a positive. Negative over positive is a negative. We could also have gone the opposite direction. Starting from the y-intercept, we could have gone up 2 and left 3. The reason is, again, because up is a positive direction, left is a negative direction. Positive divided by negative will still get us that negative. From there, we go ahead and draw our line through those points, and we've graphed our line. When we have to write an equation of the line, it's fairly simple. We just need to find our y-intercept and find our slope. So first, looking at where the line crosses the y-axis, that is at the point 1, 2, 3, 4, 5. So our b equals 5. Then we need to calculate our slope. I'm going to look for 2 points that very clearly cross at a coordinate. So right there we already have that y-axis, that's good. And then it looks like it crosses fairly nicely right there. And so my slope, I calculate how I travel. Rise over run, I go down 2, that'll be a minus 2. And I go right 1, that's a positive 1. So my slope, or my rise over run, is negative 2 over 1, which is just negative 2. We'll plug that into y equals mx plus b. Y equals negative 2x plus 5. We have written our equation of the line. That concludes our video. Remember, at the end of your notes, write a brief description of what you learned and what you still have questions on so you can ask them in class. I always like to end the videos with a little laugh. So, my joke today: what did one toilet, look, I'm a great artist, what did one toilet say to the other toilet? Anyone? Anyone? You're talking. What did he say? Oh, man, you sure look flushed today. Alright, have a great day. See you in class.